The graph of two equations are sketched in the figure at right. For each part, determine which one or more of points A, B, C, D, E, and F represent ordered pairs that. So our first thing, we're trying to find ordered pairs that satisfy equation 1. Now this is a very odd graph because we see the axes and we see the x and the y on the axes and we see some lines, but notice there's no scale, there's no grid. This is looking like it's missing a lot of information, which it is, but it does give us enough information to answer the questions. So we're looking um, for the points that would represent ordered pairs that satisfy equation 1. So let's take a look here. The graph of equation 1 is this blue one here. So notice there's that nice little graph. So if we're looking for ordered pairs that satisfy equation 1, even though we don't know what equation 1 is, any points that satisfy that equation would have to fall on the line. So we could say, well, point E falls on the line and point F also falls on that line. So both E and F would satisfy equation 1. Now the ones that satisfy equation 2, notice that that's this red line. That's this one here. This is the graph of equation 2. So if we're looking for points that would represent ordered pairs that satisfy equation 2, we're looking for points that would fall on this red line. So I see it looks like point B and point E both fall on that. And we saw point B before, or sorry, point E before, that it had satisfied equation 1. So notice that that's exactly where we're going in part C. We're looking for the points that represent ordered pairs that will satisfy both equations. If they satisfy both equations, that means that the point has to be on both lines. Well, that's going to happen here where they intersect. And so we can say that point E would represent an ordered pair that satisfies both equations. And we see that just in our answers to parts A and B. Notice that E is showing up for both of those. Now, the last thing we're trying to find is we're looking for the points that represent ordered pairs that do not satisfy either equation. So if it doesn't satisfy either equation, well, it must not be on either one of the lines. So here's a point that's not on either line. And here's a point that's not on either line. And don't let this point C fool you. It's on the axes, but notice it's not on the red or the blue line. So C also would not satisfy either. So A, C, and D, those points represent ordered pairs that would not satisfy either equation 1 or equation 2.